Hello, welcome to the AutoRob course. This is our lecture number 3. This is for covering AutoRob workflow, JavaScript and HTML5, Get, LaTeX math mode, and a bit more. This is for University of Michigan class 367, Introduction to Autonomous Robotics, as well as our graduate section, Robotics 511, Robot Operating Systems. I am the person giving the lecture in this case. So I am Chad Jenkins. I'm Professor Chad Jenkins. I'm just here at home in my home studio, still trying to do my best while we're in the quarantine situation. I hope everybody is staying healthy and safe and still in good spirits. And so hopefully I'll give you a little bit of robotics, a little bit of robotics to just help you feel good and help you advance in your career. And just your knowledge in general. So with that, we'll get to it. And there's me in the corner, so great. And so I think JavaScript and HTML5 is just an amazing language and just environment for getting things, for taking ideas in your head and turning them into code pretty quickly. And so in that regard, even just the title slide here can be taken and made into HTML. So if you just take the code right here, the text that's right here, and just put it into your favorite text editor, mine is VI. I believe now there are good people that use Emacs as well. Or you could use something else. You could use TextEdit on OS 10, or you could use Sublime Text or Notepad on Windows. Gedit, just pick your favorite one. Just copy the text in there into the text editor, and then open the file. Just open that file in a web browser, and you should be able to get this nicely formatted document that even has a link off to the course website. And so this is really cool that we can do this so quickly and so easily. We can even do more, because this environment allows us to run code and have dynamic documents, dynamic content in our web pages. So let's say that we added a little script to this that just sort of said that would print some text, append it to the body of the text, and then just have some text. Then say 2 + 2 equals. And then have an expression that can be evaluated dynamically that says add the numbers 2 + 2 together, and then put the result as a textual string out into the document. And you can see that if we open it up now, that's exactly what happens. And so we can get 2 + 2 equals 4, which is the result of running that operation. And so we can do a lot of great dynamic work in this flow. And so this same workflow is what we'll have for project 1 and all the projects in the AutoRob course. And so just to show that visually, what we'll do for assignment 1 is we'll implement a path planner, a 2-dimensional path planner that takes us from any start location to any goal locations without collisions. In this 2-dimensional world format that's implemented in JavaScript and HTML5. So we'll provide a code stencil for this, and then you'll implement an A-star planner inside of it. You can view the planner behavior in real time just by opening the file up in your web browser, and then you'll submit your code as well as just do any version tracking that you would like using a Get repository. So the way this works is that this file just sits on your local computer. You can open it anytime and see the HTML and JavaScript working, and that you see your path planner working. You can open that file into a text editor and make changes to it to change the behavior of the planner or just the runtime system, and then save that file off and view it. That follows this sort of basic coding process that you will. That whenever you want to, you will view the file by opening the HTML. You will view the behavior by opening the HTML file. You'll see the process. Then you'll update the code, save your HTML file, and that sort of is your run code test loop. And so you can just sort of do that over and over. But all this sits on your local machine. We can also have this run externally. I mean, not run externally. I'm sorry. We can save the changes that are occurring in your repository externally by committing to a repository. So I'm going to duck down a little bit. So you can have a repository that tracks the changes that happen in your code, and that repository is a Get repository. And also you can keep these changes stored remotely and tracked remotely in a remote repository that's hosted by some service. In particular, there's a number of Git hosting services. There's GitHub, there's Bitbucket, there's GitLab. If you're a University of Michigan student, there's the EECS department runs a GitLab server that everybody has access to, and so you could use that. And so all of this sort of sits remotely, and you can view the status of your repository from a web page, and then see, and then be able to look at all the different aspects of your code, and as well as any changes that were made over time. And so what you do is you can then push changes to this repository, as well as pull down changes that were made remotely as well. One thing that we're trying differently for this course this semester is to run what we call a continuous integration grader. Excuse me. And so what that's going to do is that's going to pull the state of your repository, and then be able to just run it on a machine against various tests that we have, and then we'll be able to push the results to not just your remote repository, but also locally once you pull. And so this is new. It's meant to give faster feedback. All the grades will be reviewed by the course staff. So this is not just completely automated, but we want to give you fast feedback about how well your code's working. And so, and this isn't full continuous integration, because I think in real continuous integration, every time you commit, the test is run to make sure that change is good. We're going to run this, maybe a couple times a day, just so you can get feedback about how well you're doing against our private test. You can always set up continuous integration for yourself, for your own tests, and the course staff is always willing to help you set that up. So what we're really working with in terms of implementing the code is we're using JavaScript and HTML5. And so that is what you're going to use for all of the course projects. In this case, we provide a code stencil for doing this, which is the KinEval code stencil. KinEval stands for Kinematic Evaluator. And this basically allows you, provides a stencil so that you can use. So we try to hide all the details that are needed to make this run, so you can focus mostly on the robotics aspect of this. And one thing I love about it is that it's very portable. So it works in all of your modern web browsers. So Firefox, Chrome, Opera, you name it. Your code should work, and so it provides great portability as far as I'm concerned. You can find the KinEval stencil from the course webpage. So if you go to AutoRob.org, there's just a little link right there that takes you to the KinEval stencil that's available on GitHub. And so we'll talk more about what it means for this repo to be there, but you have access to it right away. But before we dive into this, we should just talk about what is JavaScript and HTML5. What does this really mean? What is it? What is this in environment? And so I believe JavaScript and HTML5 is just an amazing way to go from idea to code really quickly. It has strengths and weaknesses with respect to other languages, other ways of other runtime environments. But I think this is something that I think is good for prototyping. What JavaScript and HTML5 is to really describe it with respect to people that have programmed before or thought about programming. I would say that you have to consider a spectrum of programming languages when you're looking at what is JavaScript and HTML5. And so that spectrum exists. There's two real extremes on that spectrum. And so one is that you want to, let's say you want to get something done right. You want to make sure that it performs well, it's robust, it's reusable. It's got all of the sort of hardness that we want out of really robust and production code, or just something that's solid. In that case, I was trained as a C programmer in the beginning, and that is the language that I go back to when I really want to get something done. So C, and maybe if you don't like typedef struct and you really want to use C++, you could do that too. But C to me is the go-to. On the other end of the spectrum, which is to me just as good, you can get things done quickly. And so that really is go from idea to code fast, rapid development, being able to visualize results quickly and have them disseminated to a wide number of people, and just sort of, this is sort of, getting things prototyped and out there. And so to me, the choices that are great on this side are MATLAB if you really need good numerics, or JavaScript, which runs on pretty much everything. And so to me, if, depending on what you want, the ends of this spectrum are really where you want to be. But sometimes we have to have trade-offs. And so I see, there's these trade-offs that we make in the middle. And as you get closer and closer to the middle, things get worse and worse and worse, because you have these sort of suboptimal trade-offs in terms of the readability of your code, the mixed performance, because you have to compile things down to another language, or you have to do some sort of interpretation strategy, and then just the overhead cost of building and running, and so languages exist on the spectrum. To my sort of my dismay, Python is right in the middle of it. Python is not my favorite, but I know that the world disagrees with me on that. Everybody can have their own opinions. But what JavaScript in this regard, there's no free lunch in this. And so JavaScript does have pros and cons. And JavaScript has, it is, the thing that I love about it is free and it's open. It's portable, works on everything, has great visualization, and has a reasonable learning curve. I don't think it's that bad. It does, as I'll say, I think this, it translates well to C++ style thinking. It's very flexible. There's no rigid typing structure, so you can pretty much do anything, and you can get live introspection. And that's great. But a lot of what these pros are also cons, in that there's limited network access because for very valid security reasons. It's not very good about input output to files and things like that. It's not really great for numerics at all, given how it represents floating point numbers as in IEEE 754 format. It is, if you want to do something in an efficient and performant way, JavaScript is not the way to do it. Weak typing, which can be seen as a plus, can also be seen as a negative. So we can think of as a JavaScript as C without discipline. And the debugging messages that we get from JavaScript are not the easiest to interpret. There's still a lot that we have to. There's still a long way to go there in that regard. I do think of JavaScript as C without discipline. So if you are familiar in C, or what Douglas Crockford would say is a classical programming language, then I think you can adapt to JavaScript pretty quickly, given that there are there's some things like prototyped objects and maybe minor syntactical differences, and so just using your instincts in Stack Overflow with a few resources, it's pretty good. If you're familiar with a scientific language like MATLAB or Mathematica or something like that, you may take some time to get familiar with JavaScript. But you should be able to get by with figuring out some things about the syntax and data structures and what we're going to talk about in this lecture. If you're new to programming, there's going to be a bit of a learning curve, and so it's highly recommended that you would take a course like EECS 402 or EECS 280, or the new course that's being offered, which is Rob 502, Programming for Robotics. These are highly recommended for you to take either as a prerequisite to this course or in parallel to this course. And so we'll do our best to help people that don't have programming experience. But you should know that this is gonna take some work on your part, but also the course staff is here to help you through that as well. So again, what is JavaScript and HTML5? Let's take another approach to it, and just be more definitional about it, and say that really JavaScript and HTML5 are the essential technologies for creating and rendering web pages, that we've come accustomed to in the common ecosystem. And so that includes not just JavaScript and HTML5, but also cascading style sheets, CSS. These define the runtime environment of the web browser. JavaScript. So what HTML5 actually is hypertext markup language version 5. This expresses web pages as documents and they're stored in HTML files. And so underlying this is really the document object model representation of how we can represent a document and the various elements in it as a hierarchy of objects. JavaScript then is a high-level dynamic programming language that allows to access the document object model and programmatically automate aspects of it and change it dynamically. And then cascading style sheet sits within this as a style sheet language that's used to describe how we present things. So it's a way we express the style of the document. In representing that style structure that can be ported to many different documents. The document object model is really is how we're representing a document as a collection of objects in a structure. So HTML documents are defined by nested tags. So if you ever look inside of an HTML and you see H1 inside of these little brackets, and then it has a closing bracket, that is really specifying what kind of object sits there. And so JavaScript provides programmatic access to these. One thing that you should know when you're thinking about the document object model, there's a couple of built-in higher level objects that actually exist. So if you're viewing something in a window, in a browser window, the highest level object that you can have is something called the window object. And so if you're familiar with programming, when you create a global variable inside of a web page, that global variable isn't actually just something that sits off in space. That actually gets scoped into the window object, and window maintains the global context. So your global variable. So if you make a global variable x, that's actually window.x. And inside of window, there's actually a document object, and that maintains the state of the document that you're seeing, and that gets populated upon loading. And then every object has a style property, which is expressed in the cascading style sheets. And so we can start with a simple example that sort of shows what this looks like. So if you were able to see inside of the course repository, there's a JavaScript by example and a couple of animation examples, but there's also a hello.html. And so if we took that page and we were able to load it into our browser, we would able to see that we would get a document object model structure that looks like this. And so this is basically taking that file and parsing it into the various objects. And so we can take these. So if we move this over to the side and we look at it with respect to, we look at this object structure with respect to the actual HTML that we're seeing, we can break this down one by one. We can break the file down and look and see how the document object model is being structured. First, we're going to look at in the document, you'll see that there are the HTML tags. HTML specifies that this is going to be the root element of the document, and so that really is saying that this is what's contained all inside of the document. Then we have inside of that the body tags. So this is the body of our document. That body is going to have the essence of the main structure, the main contents of our document. When we get to the first sort of bit of substance that we have, you should note that we have an H1 tag. This is a heading 1 tag that will say my name big. So any text that's inside there will be shown in big as sort of a heading 1. And so if we go and we look at the text that's in there, that's my name, that's Chad. We can see that shows up as heading 1. There's some just miscellaneous text that's sort of sitting out there, and so that's attached to the body, and so that text is just here. We can be more specific and say that we can have text inside of a new paragraph. So the P markers. So we have an opening P marker and a closing P marker that specifies that there's a paragraph. And so when we have the text in here, that's going to start a new paragraph and it'll show up this way. Then we also have a canvas. A canvas is basically creates an element of a particular width and height that you can start to draw on and make different types of figures and shapes. So if we put that element there, that element will be width 400 and height 400, and then we will be able to that canvas we can draw on. We don't draw on it maybe direct. Maybe we can have some text that's inside of the canvas, but we could use JavaScript to actually specify how we should be drawing inside of this canvas. And so we can specify JavaScript statements to be executed by the browser with inside of these script tags. So we have an opening script tag and a close script tag. And then when we execute the code that's inside of this, what that will do is that will grab a reference to the canvas element that's named, that has the identifier my canvas. It will set up a drawing context and then essentially execute these 5 fill rectangle statements that will just draw 5 rectangles that show the shape that we're seeing here. That's supposed to be a pirate. So, rawr, or yar. Anyway. So we should talk. So that gives us the general structure of HTML5. But inside of those script tags, we can write JavaScript. And so let me go through some of the aspects of the JavaScript language. To do this, we have a JavaScript tutorial by example, because I personally learned best through coding things myself as well. And so we can have this tutorial by example. And so you can look at that along with while we go through this to just give a sense of what the language can do and the different features of it. So if you just click on it, you'll get this output. And so this output is just showing what would result from running this code. But the real thing that you should be looking at is inside the browser. So if you open view source inside the browser, you would be able to see the actual code that's run in this. And so we have some stuff at the top level, just to provide some context, but really the meat of it is inside of this file called jsoverview.js. Inside of there, you'll see that we have that will call this function tutorial.js coding, and that sort of goes through a number of different, just shows examples of how we would use JavaScript in this context. And so, for example, some of the first lines that you'll see are things that create variables in JavaScript. So variables are just an empty container of some information that we can store. That could be a number, it could be a Boolean value that says true or false. It could be a string, a pointer to a string that has just as a string of text. And so these variables become defined when they're first assigned. You don't have to declare them. You could just say, I'm going to make the name of a name of some variable, and then use equal to assign it to some value. So in this case, the variable that we're calling, that we created here called string global, is being assigned to the string that says this is a global variable. The equal sign will allow you to do assignment of this variable. The next one we're calling whenever we put the var reserved word in front of the variable, that will be a locally spaced variable. So that will be a variable that's only known within the local scope of a particular function or block of code, and we're assigning this Boolean value true. At the bottom here, our last statement is assigning a number to the variable number local, the global variable number local, which will be assigned a value of 2, which is 20 minus 18. One thing that you should note is that comments are provided, that you can have a commenting mechanism. So if you have a double slash, for instance, what that will do is ignore the remainder of a line. So in this case, I have I put the double slashes and I made a comment to myself: is this variable local or not? But it is local, or it's not local. It's a global variable, I should be clear. And so so we can make notes to ourselves using those comments. And if you have good coding style, you're leaving lots of notes to yourself, so that you're documenting your code, so that it's clear what the functionality of that code is, and you don't have to spend a lot of time interpreting it. If we think about what this looks like, what we could think of these as sort of like small as containers, and so if we could think about each of these assignments providing having a variable name. So I'm going to pop myself up. I'm going to pop myself up real quick. So we could think of these. We could think of each variable name. So we assign into string global, and that variable name also has an associated value. And so whenever we make an assignment, we can create that's for a new variable. We're creating this variable name, and then we're storing it. We're storing something into this box. And so the same thing for Boolean local. We're creating this box, and then we're storing something inside of it, and we can always retrieve that or change it if needed. And so that's something we can do. In addition to storing those what we call primitive types, such as number, object, or string, we can also store more complex data structures. So, for instance, we can have the basic type of this is an object in JavaScript, and so what that does is maintains a collection of keys and values. So when we create an object, we can say, we can create an empty object by assigning something in curly braces, and so that creates an empty object. And then what we can do is assign into sub-objects, so to what we call properties, or to these keys, we can assign values as like they are any other variable. So for instance, if I created my object and then I wanted to say, .university, I can assign a string to my object .university, and that will equal Michigan. And then I can create another variable inside of this data structure that would be department. And so I could say my object department is EECS. We should note that in both cases, both for my object .university and my object in brackets with the string department are equivalent expressions of how we can specify key values or keys of the object. And so we can put whatever we can have a number of collection of these variables that sit inside of this object structure. If we could alternatively specify this instead of a collection of assignment statements. We can use the JavaScript object notation, which is called JSON. And so JSON just provides a more compact way of saying the same thing. And I'll leave it to you to think about if you want to express things as statements or as JSON. There's pros and cons both ways, although JSON is pretty nice representation. Once we execute, so when the browser goes through and executes all of these lines of code, so it executes them one by one, in memory, what we could think of what this looks like in the computer's memory is a pointer. So my object is essentially a reference to this data structure that sits off in memory. So my object points to the structure that has university being assigned to Michigan, department being assigned to EECS, course number being assigned to 367. And so that's what an object would look like. And so we can start to do things, we can start to look at what would happen if we start to make assignments of objects. So when I assign a primitive type, then it overwrites the data that we had before. But if I assign an object to a new variable, it doesn't do what's called a deep copy, where it copies everything over. What it actually does is make a copy of the reference. So what happens in this case is that my object makes a copy. The reference gets copied over to copied object. But they both point to the same data structure, which is really a really important thing to know. Because now if I make some change to the copied object, that's actually making a change to both objects. So in this case, if I change this value to 5, if I change the course number value from 367 to 567, that will actually change the value for my object as well. And so that can lead to real problems if you're not careful. So we can verify this in the console after running all of this, that if we say, after modifying the copied object, if we ask, well, what was that same value for my object, we'll get the modified value. So you do really have to be careful with that. There are other types of objects that are important too. So there are arrays. So an array is an object, except that instead of allowing for keys to be sort of any type of string or expression, it's specifically for numeric keys. So for instance, if I create a new array like that's of this form, so this is an array, this is a new array. What that will look like in memory is something that looks like this, where I'm blocking this now. I'm going to go off for a second. So in this case, that creates a new structure where each of these elements, 8, 6, 7, 5, 3, 0, 9, are assigned to a sequence of indices that are increasing in their number. We should note that all arrays have a length property. So the length of the array that we just created is 7. So we can always look at the dot length property of an array object, and it will give us the length of that array. We should note that we can nest objects inside of other objects. And so one way we can do this is we could create a property of the my object object, and then just assign, we can call that property phone number, and we can simply just assign my array to that property. And so if we did that, what that would look like in memory is making a copy of this reference and then adding that to the object that we've created previously. And just as before, we can modify that object and we can modify that object, and it will be reflected in all the other objects that are pointing to this. JavaScript also has dynamic typing, so that means that if I have an object of a particular type and I say assign an object of another type, then that will just change that type automatically. So for instance, if I took the last element of the phone number and I changed it from 9 to 99, then that will actually just change this it will change it from type number to type string. And then so in that case we will have that's sort of an issue that just shows sort of the dynamic typing that can happen. There's also, for anybody that's used to our classical programming languages, there are control statements that we have. So JavaScript supports if else type commands. So, those are conditionals that say and so these are just examples of that, as well as your C style for loops that you're seeing here. And so, so we can iterate through that array and print out each of the elements. And so I'm not going to cover that in depth, but those are very easy to look up and see how to use. We should note that there are a number of operators that are available in JavaScript. And so there are grouping operators such as the commenting. So operators that will comment out code. There are grouping operators such as the parentheses. A lot of mathematical operators, increment and decrement, arithmetic, comparison, assignment. I should note one of the things whenever you looking at JavaScript and you see, I'm going to bring myself back. Whenever you see the triple equal sign, that means strict equality. That means that these two, the things that you're comparing have to be equivalent. If you use the double equal sign, JavaScript will try to do some things to match types and do some casting for you. So you should note that there is a difference between those two. And so I want to go off on a brief tangent here real quick and just talk about LaTeX math mode. And so when we're talking about arithmetic, usually it's kind of cumbersome to express it in in JavaScript, when we're talking, it's much easier to do it symbolically in math expressions. So when we're talking, so when we're having discussions by email or through the discussion channel, I tend to use LaTeX math mode as a way of expressing mathematical expressions. So for instance, you might see a post on I say Slack. We don't use Slack anymore. We use Microsoft Teams. But you'll see me say something like blah 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 blah, end effector vector, and then I'll use inside of dollar signs you'll see these symbolic statements. Well, what that really is that's sort of using LaTeX math mode to express this. And so what you should interpret this message as is what you're seeing below. In that what we have is I'm expressing in the first double dollar sign is actually a vector xy transposed. And then in the next one is a distance function. So you're taking the square root of x and y, or of xi squared plus y squared. And so that's just your distance function. And then we're using subscripts with this as well. So I'm not expecting everybody to learn LaTeX, but that's just how we express math. If you want to know more about it, you can go to, so Overleaf has a really good math mode sort of guide that sort of gives the high levels of it. If you don't care about it, you can always download one of the LaTeX equation editors. I like LaTeX it myself. And you can just take whatever text is there, and then just plop it, then just copy paste it into the editor, and it'll show you it'll actually do the interpretation of the math for you. And so that's just something that's good to know ahead of time. Coming back, here's a quick question for you. What is this expression? What if I had to express that as a number, what would that be? I'll let you think about that while I get a little bit of water. If you thought about it, is it 16 or is it 1? Maybe. We got to think about it. But one thing that doesn't have to think about it is JavaScript, because what you'll note is that we have an order of precedence with all the operators. And so this order of precedence lets us disambiguate problems like that, so we don't have any ambiguity about how to evaluate those expressions. And so I will leave it to you to decide what the actual true answer is. And so one thing that you should then, so that order of precedence is really important. You can take a look at that. We should also note that some of these operators are overloaded. So the plus, for instance, is overloaded to not just add numbers together, but it also concatenates strings. And so we can look at this in the case of a new concept that we'll call a function. A function is an object, and is a type of object that executes a set of statements and optionally returns a variable. So, for instance, we can create a function. Gotta go to my nerd glasses here. There we go. A function. In this case, we can create a function that performs a sum. In particular, a sum of two numbers. And so so this function declaration just sort of sits here in the first. In the function called sum, it adds together a plus b and returns the result. So if we call this function, we come down and we call this function. We say we want to say sum the number 3 and the number 67. It will perform as we're expecting, and return 70, 3 plus 67. However, if we give the same function a string that says 3 and a string that says 67. Instead of getting 70 back, what we'll get is the concatenation of those two strings. They're going through the plus operator, and that will return 367. And so we should note that depending on the types of the variables, the plus operator can do two different things. With JavaScript, with functions, JavaScript supports recursion. So recursion is a function calling itself. As a canonical example for this is the factorial function. So imagine we have a function of this form where it considers one of two cases whenever, based off of a value that's given to it, which is a numeric value, an integer value in particular. So if that input number is greater than 1, then what the function will do is take that number and will call itself with 1 minus that number and retrieve that result, and then retrieve that result. So for instance, we can consider 6 factorial to be the number 6 times 5 factorial, and 5 factorial would be calling the number recursively upon itself. And so we will do that until we hit the base case, which is 1, because the factorial of 1 is 1. And so we will return 1 in that case. Once we do that, then we can hit that base case and pop back up. Let me go through a detailed example of this so it makes a little bit more sense. JavaScript maintains a function call stack. So whenever there is whenever a function is called, all the state of the function at that point where the function is called is stored, and then we can move on to the next level of function. And so this call stack, when it starts off, is going to start off by saying, well, we're going to make this assignment of factorial number equals factorial of 6. A variable factorial number is going to equal the calling of the fact function with the number 6, and so we're going to push that onto the function call stack, and so that's gonna go on top of the stack. And then when we go into the function is going to say, all right, now we have now for this function, what we're going to have to return is going to be in the input number that's given to us, 6 times the factorial of that number minus 1. And so we're going to end up calling this function again inside of itself, and that's going to create a new function call with its own local variable scope. And so that will then be pushed onto our function call stack. Once we go inside of that, it's going to say, well, we need to take this number 5 that has now been given to us by this other function and multiply it by the factorial of 5 minus 1, which would be 4. And so we're going to do that again, and then the factorial of 4 is going to have to do the same thing, and then factorial 3 is going to have to do the same thing, factorial 2 is going to have to do the same thing, and then we hit the base case where factorial 1, well, we know what that is. We don't have to recurse any further. We can just at that point know that we're just going to return the value of 1, and then return that value to the next level, to the higher level of the function call stack, and put it into that location. Once that's done, now factorial 2 has all the information it needs to then return its value. So it's going to multiply those together and produce a value of 2 that is returned to the next level of function call stack. This then happens again for factorial 3. We multiply it together. 3 times 2 gets 6. That is then returned. 4 times 6 for 4 gives 24, which is 4 factorial. Then we have the same thing for factorial 5, which will return 120. And then we'll finally get back to our original function call, which is going to return the factorial of 6 as 720. And then that can be assigned to the variable that was in the original assignment. We oftentimes have to cover these things multiple times. So as much as I would love to discuss just the robotics of what we do, being able to deal with coding errors and things like that can be a continual struggle. I can tell you the innumerable numbers of times I've been on office hours, and we just sort of sort through all of this stuff, and we figure out that there was just some small coding error that was causing the behaviors that we were seeing. In these cases, the browser console can be a very good friend, one of your best friends, when you need to debug these types of issues. And so the browser console is provided by the browser to log information that's associated with running a page in real time. It logs errors, warnings, explicit logging messages, live requests, security errors, and it also provides live introspection so that you can interact with your web page that's running or your code that's running with JavaScript expression in real time. And so that's really helpful, and you can walk through your code. So this debugging is I think is pretty good. So say for instance, we go back to the example that I created. If you go into your web browser, you can look and find the web console. Well, you can find the web console up there. So, web console or browser console, every browser is different and every versions may be different. But once you find it, you click on it, you'll see some windows show up that maybe look something like this. And so this area right here can show you is where console messages are being logged. And then you also have space at the bottom for evaluating expressions live. So say for instance, we started just typing some things into this. So we could start by saying 6 plus 2, and we get a response that says 8. We could say take 2 to the third power. So we use the power function inside of the math object, and that would give us as 8 as well. We can test our string concatenation by saying take the string with 6 plus 2. We can assign a string. We could also evaluate for loops. So we can have a for loop that just started from 0 and counted up to 9 before we got to 10. And we can append that to the string that we created by using the plus operator. And so we can evaluate all of those expressions live in the browser console. In addition, it gives us a way of interacting with the DOM as well. So let's say that I just wanted to wipe out everything that was in the body.html, wipe it all. I can just assign this new text that we've created to be the body of the HTML. And now I've just created I've just wiped out everything in the document and created just new text there. And so we can interact with this document live through the browser console. You can use the browser console also for debugging. So there's a debugger in the browser. So if you open the web console again, and then selected debugger to get to the debugger, what you can do is you can set things like breakpoints. And so you can go in and say stop on this line. And so you can let the code play, but when it gets that line, it will stop. At that point, you can do things. You can look you can start to evaluate. You can go back to the console and type expressions to be evaluated. You can put in watches to watch what a variable sort of looks like and study it over time to analyze what it's doing in case there's something wrong. And then you can also step through the code one line at a time. So you don't have to, so you're not trying to race against the code to see what happens at different places. You can step through it deliberately. And so this is just a good thing to do to just figure out what's happening with every line of code. So one thing we can do is we can try just to see this happening, because robotics is, we have live things working. You can have a live example of an animation that's working as well. And so in the code directory, there's also hello animation. And so this is just a ball just bouncing up and down. And so the code for doing that is in the repository. All it is just taking a ball and making it bounce along a sine wave. You'll note that there are certain things that this document only consists of really two objects, or really three objects as we had before. Text object that says what's the current location of the ball, a canvas that we can draw on top of, and then a script. And within the script object is the JavaScript that we're using to run the code and generate the animations. Inside of this is really run by what's called inside of this function called animate. And what animate does, it does three main things. It does an update of the state of the ball based off of so it can produce the bounce, so it can update the location of the ball to represent the bouncing motion. it will have a draw function that will redraw the screen so that we can update the visuals for what the current state looks like. But it also will call this function called request animation frame. And we'll call that with the function of animate itself. And the purpose of this request animation frame is to make sure that animate gets called again in the near future. And so it'll get called at some very small delta time in the future. And so what happens is that it puts in what's called a callback to make sure that animate gets called again. And so what happens is, in order to produce this animation, is that animate is being called over and over and over based off of the request from request animation frame. And so that's what's allowing our code to draw. And one thing that's really important is that in order for this to work and work well, the update and draw functions have to be fast. They can't do what's called blocking. So if you ever see the browser go unresponsive, it's because the code is blocking. And so that's just clogging up the works. And so you got to make sure that your code is responsive and it's not blocking, and so that's just really important. So then in this update function, you should note that in order to get the current state of the world and draw on the canvas, we just use document get element by ID that will return a reference to any DOM object that has that is named this that has this particular name. And so that's how we get the reference to the canvas so we can start to draw on top of it. You can run. There's also one more animation example that you can run on your own. And so that's sort of the text. I just have one that's having text that's dropping over. I wrote this back when this was a special topics course, so you could try that as well. And there's also many other examples online. I mean, too many to list. I'll just say some that I have. So if you want to see a super quadric, so a super quadric is like, imagine an ellipse, but you can then change the exponent to be whatever you want. And so you can get all sorts of interesting shapes. You can pull that off of my GitHub and just run the code, or you can just see it live and you can just go to I believe this link still works, at least the last time I tried. And you can see just sort of an example that, you can see an example just live in your browser and just play around with the shape and change some of the parameters. And so this gets to the stencil repository. And so using Git in order to do this. So what we have is a lot of JavaScript and HTML5 code that sits in this repository that you can use for the projects in this course. So you should know how to use that code now that you know about JavaScript and how it works. But what is that Git repository? And so what really it is doing for us is what's called version control. Version control is really about how we can maintain the past history of changes to your code or just any project. It maintains this history repository as a collection of as what we call commits. And so those commits are changes from one. So we were logging the changes of one commit to the next. And the basic workflow is that your code is checked out of a repository or pulled from a repository, modified, then checked back in and committed to the repository. And that the repository remains this history of diffs or changes between before and after, before checking in a commit. You should note that I got started using the CVS, and so I still think of things as checking in and checking out. I know that doesn't quite make as much sense in the 2020 context, but I use this stuff all the time. It's not just sort of it's something that I use on a continual basis. So consider for instance the TED Talk I did several years back. So this TED Talk was done with Henry Evans, and so we basically flew drones and drove robots on the stage and a number of things. But in order to fly that drone, we had to do a little bit of hacking, a little bit of code development in order to make it work. Because I'm in Washington D.C. and at that time Henry's in Palo Alto, California, and so we've got some coordination to do to make all of this work. And so what he was doing is controlling his code, controlling the drone that was on stage in D.C. literally across the country, 3,000 miles away, through an application we developed in the browser that's using ROS-Bridge in order to make this connection. So the same ROS-Bridge that you'll use to connect your code in from KinEval to one of our robots, he was using that to drive a drone on stage. In order to make that application, what we had to do was there was like just a simple repository that has the code that creates the interface, makes the connection to the robot, makes sure that invokes all the right commands and things like that. And so we're working on that together. And so there's a history of changes that we're seeing. This is for old version of ROS and ROS-Bridge. So there hasn't been a lot of commits recently, but up until that point, we're basically keeping a log of all our changes and giving them descriptive messages that tell us what happened during that change. And so that's really just this is sort of a really small project. But this is how this works for large open source projects too. One of them I'm involved with is the Robot Web Tools project, and so that's to make robots available to web browsers, so that we can code robots through web browsers, but also control them and make user interfaces for crowdsourcing, greater accessibility. And in fact, MATLAB, connection from robots to MATLAB was at least at one point one of the major uses of robot web tools. But in order to do it, we have to maintain a pretty reasonable code base. And when I say I mean the actual maintainers of it, Ji-Hoon Lee, and Russell Torres, people like that. I think there are lots of other new people that have come on to maintain. But as of September 2016, we had a large number of commits and a sizable number of contributors, which has just grown over time. So 2017, we're getting more commits and more contributors. 2018, 2019. I take a screenshot before each time I give this lecture. And so, so the number of contributors is growing, the number of commits is growing. This can get out of control. When I took a screenshot of this the other day, 727 commits. How do we keep track of all this? And Git does a lot of this work for us so that we can be good collaborators. And so they have a commit history. So if somebody does something that was not nice or not good, we can always revert our code back to some prior state in the history all throughout the project. We can also keep a change log so that we can see what happened between commits, and so we can see those diffs that are happening. And so this really is a powerful thing, and it's great for collaboration. I'm not even mentioning the pull requests that are happening and the testing that's integrated with this. And so this is really good. There are a number of options that you could use for version control. One is the concurrent versioning system, which is very old school. That is what I used in graduate school. So I just still have to mention it because it still has a special place in my heart. And they still may be used, but Subversion and Mercurial were out there. I don't know if they're being used anymore. And Git really is sort of the dominant version control option that we use in AutoRob, but is in widespread use right now. So when you're thinking about Git, what it's really doing is it's storing things into these different places. When you're thinking about what you're actually seeing right now, that is your workspace. That is where you're working right now. And then that workspace, as you make commits, go into a local version of your repository. And then that local version of your repository can be synced and can be pulled and pushed and synced with a remote repository that could be somewhere on some other Git server, usually somewhere on the cloud. So you can think of the directory where you're working right now as someplace on your local file system. The repository would be in that sort of usually in that local workspace, but as the hidden directory .git. And then the repository, then your actual repository on the remote server would be accessed through usually some URL with, in my case, with a unique name. I actually probably need to put my the actual repo name on that. Maybe that's hidden. I'm sure I'll have to maybe correct my slides. And so what happens is when you make a change to your workspace, what you have to do is then add that file if you need it, if you're creating a new file. But if you make changes to an existing file, you commit it from your workspace into your repository, and then you can then push into your remote repository. And so if you don't have any files to add, just commit and push. And then if you have changes that happen in your remote repository and you want to bring them locally, you can do a pull, and a pull will bring items from your repository, from the remote, into your local workspace for you to then make changes. There are a number of Git commands that you could use that the GSIs, the course staff, will cover during the tutorials that we'll have during the discussion sections for the course. But just to say this, you can use git add to add new files, commit to commit them to the repository, push and pull. So that's just showing these files. We have a number of examples that sit inside of the KinEval stencil that just sort of shows how this sort of fits, what the structure of the repo for the KinEval stencil, such as the tutorial examples that I covered now. Before we last in the lecture, we covered A-star planning. Before you do that, maybe you want to start with the heap sort so that you can make sure that your heap implementation is working well. And so the heap sort is essentially just inserting a random collection of numbers onto a heap, and then we can extract them one by one. And the result of that extraction, the order from that extraction, will lead to sorting of the numbers. And so that exists there. You can play around with that. In this directory for project path plan, that is the stencil for path planning. That's where you're going to implement project 1. In project 2, you're going to do a pendulum dynamics and control. This is the pendulum assignment that sits in this directory right here. And then for assignments 3 and 6, we're going to cover robot modeling control. That's mostly done. That is done through the home.html. That's going to cover. That's going to access files that you're going to modify inside of the KinEval subdirectory. One question: let me say this, if you were this guy, and you should think about who this guy is. If I presented this repository to you, this code stencil, what do you think this guy would say? Take a sip of my water while you think about that, and maybe look this guy up. So if your search was successful, or you're just in the know, you'd know that that's Jaron Lanier. And one thing that he might want to ask is, who owns the code? Is this my code, or is this your code? What's the status of this, right? And I hope this would be a good, hope Jaron would like this response. It would be, we both of us own this code, right? And there's a good reason for that. And really, this is, well, the way you should think of it is, we are a development team together. We are both working on this code and trying to get it to a state where it's functioning properly. And so one thing that you should look at is inside of the repository as well, that there's a file called license. And so that license file is something that you should have on all your projects. You shouldn't have code that just is sitting out there with unlicensed, because then nobody really owns it and nobody knows what to do with it. The license makes it very clear who owns the code and how this code can be used. And so in this case, the KinEval stencil, which was written by me, and has other contributors that have added onto it, is subject to something we're now calling the Michigan Honor License, or I'm calling it the Michigan Honor License. I should just be honest, I'm not a lawyer, so I don't even know if this is what this actually means, but parts of this do mean very specific things. So what the Michigan Honor License is, it consists of five parts, 5 clauses, And these are really to assert intellectual property and academic integrity. And so the academic integrity is sort of what I know a little bit more about. The first three clauses are really just straight from the BSD 3-clause license, and so you can read that, which basically means that you have to give notice that this is a copyright license, and that you have to that the conditions of open source software. The fourth clause is essentially the Michigan Engineering Honor Code, which means that if you're using this code, that you're certifying that you haven't used any other code from this repository, from this course, that has been generated from past classes, and also that you will not give it freely to students in future classes. That essentially means you have to do your own work. And similarly, there's sort of a attribution. I wouldn't call it Creative Commons attribution 4.0, but it's something like it, which basically says that if you're using this code for a manuscript or using the source, you have to acknowledge that this is from our project. And so this really is the Michigan Honor License. What you have to do in order, if you want us to grade your code, so you have to go down to the bottom right here, and where it says, and so Lizzie added code this year, so you can see her name. Well, here we go, and you can see her name right there. Actually, I'm gonna go big for this. Wait, that's the wrong mouse. All right, so there's me right here. So I wrote the code. So I wrote the original stencil. So that's here. Lizzie added code this year, so she's right there. And then you should add your name right there. You can be, I am a good student in this case. To put your code, and what that does is that asserts the license file. So it basically means that you are subject to the honor code, and we need you to certify that in order to provide grades. I should just note, KinEval, the license file, is still a work in progress. I need to do a lot of things with it. I need to make sure that we recognize numeric JS, which is one of our dependencies, 3JS, which is another one of our dependencies. Anytime you bring something new in, you should be attributing it and making sure that you're asserting their license as well. I'm not doing that just yet. I'm just going to throw my hands up and say, Professor, I don't have enough time. I'm an academic. Don't hurt me. And there's a lot of professor code for this. I don't get enough time. I would love to do a lot more with this code, but but my life is really budgets, email, and PowerPoint, or Keynote, I should say Keynote. So don't hurt me too bad, but we should know that there is proper practice in order to do this. And so one question you should ask yourself is, if we're doing this CI grader, and the grader's coming in and looking and analyzing your code, but we're both looking at the same repository. How is the grader looking at the right version of the code and code that you might be breaking, while in order to get your in order to get your next project working? And so how do you work on your next project while we're still grading your last project out of the same repository? And the answer to that is branching. And so branching is a feature of Git that allows us to do this seamlessly. So in branching, what you can do is, it's good for collaborative projects. Allows for different versions of the code to be modified in parallel. Branches can be tagged, and branches can be checked out, and you can create new branches off of a certain state of the repository. And then when you want to merge a branch back in into another branch, you can do a pull request, or you can do a merge, and that will bring it back in. So what we would suggest is that in your master branch, which is the thing that we will be grading off of, you should continue. That should maintain always working code that we can grade. Now, but you can also branch off of that master into an experimental or a developmental branch. And then that developmental branch can then you can then make changes to that, and you can break stuff and and not having to worry about it being graded. But then when that developmental branch is ready to go, it can be merged back into the master, and then it will be ready for grading. Whenever you wanna create a branch, you can check out a branch name, and whenever you want to merge, you can merge two branches back together. So that's how this works. I'm gonna skip that. I would highly recommend the learning branch and get tutorial. I mean, branching, it's an amazing feature, but it also is sort of like it can be overwhelming sometimes, and you're always afraid of, am I doing the right thing? And so one practice that I have is I may keep like an archival version of my repository in case I do something really wrong. I can come back and reclone that. So it's almost version over the repository itself. Because you can get into trouble quickly if you don't know what you're doing. But once you learn it, it's amazing. So for the AutoRob course, we should note that that there should be no collaborator conflicts. Although I think we're going to change things this year and allow for make the stencil an upstream repository. So Lizzie is going to talk about that and things that we could do. But you should note that all of your code should be contributing on master. The thing that we contribute for the most part is grading and updates to the stencil. And so this is how you can keep your projects updated. And so just giving a little bit of foreshadowing on Project 3. So what you can do if you want to, so this is where Project 3 is where we're really going to start in on using the robots and modeling and controlling a number of different robots. So what you can do is, if you want to just try this, you can go clone the stencil repository. So get clone and then the repository of the KinEval stencil. And so assuming you have Git installed, it will bring everything down. You can go into home.html and view that into your web browser. And so that should show things up and running. And so you'll see the pieces of a particular robot either bouncing around or jittering or something like that. If you want to just see how these things work in situ, you can go to KinEval starting.point.js to just sort of see, it's sort of like the old tutorial that we ran for JavaScript when this used to be Project 1. And so you might need to I'm going to skip that note. And so when you run KinEval, if you run in Firefox is usually good about letting you just open up an HTML file and then running it. Some other browsers may be a little bit particular because they're like, what is this local file you want me to run? This just seems sketchy. And so it will throw a security error. So what it really wants you to do is serve this page from an HTML file. Or from an HTTP server. So what you can do is, one thing you can do is, if you have Python on your system, you can go and start the simple HTTP server module and you're in your local workspace, in the workspace of the repository. And so this is just one example. And then this will create a local HTTP server from which you can see the file. So if you then browse to localhost 800, that will give you access to the file and show it running in the browser. If you don't like Python, you want to do Node.js instead, and you have Node.js installed, then you can install the simple server module and do something and then run Node with the simple server module that will run a HTTP server out of your local directory. And so you can go to localhost port 3000 home.html. And so if you're successful, you should see things running in the browser, a 3D view. You can click the mouse and have it move around and do all sorts of stuff. And so that will just show that you can get the stencil and just at least see things working, and your working environment will be able to get things done. We're going to do more with this later as we get further along in the class. And so I'm just really just going to stop there and just say say thanks for listening, and happy hacking. Good luck on Project 1, and make progress. Thank you.